It is 1:23 in the morning, April 26, 1986, in the windowless control room of Reactor Number 4 at the Chernobyl Nuclear Power Plant, buried inside a concrete building in northern Ukraine. Two operators face a wall of flickering gauges and chrome buttons. Alexander Akimov, 32, glances at Leonid Toptunov, 25, seated at the reactor control panel. The test is nearly complete, and then one of them reaches for a red button marked as E5, the emergency shutdown. It is the last decision either man will ever make as engineers. The Chernobyl Nuclear Power Plant, named after the medieval town 14 kilometers away, was the pride of Soviet nuclear engineering. Its 4 RBMK 1000 reactors, massive graphite moderated machines, each produced 1,000 megawatts of thermal energy. Reactor 4 had come online just 3 years earlier, in 1983, but the RBMK design possessed a dangerous secret. A positive void coefficient meant that if steam bubbles formed inside the core, the nuclear reaction did not slow, it accelerated. More critically, the control rods carried a hidden flaw: graphite displacers at their tips. Under certain conditions, inserting these rods to shut the reactor down could instead trigger a runaway surge. This flaw had been discovered at the Ignalina plant in 1983, then buried in Soviet bureaucracy, never shared with the men operating Reactor 4. The test scheduled for that night was, on paper, routine. Engineers wanted to answer a single question: if the plant lost external power, could the spinning inertia of the turbine generators supply electricity to the cooling pumps long enough, roughly 40 to 60 seconds, for the diesel backup generators to activate? It was called a turbine rundown test. It had been attempted once before, in 1985, and failed. This time, new voltage regulators had been installed. The team believed they had solved the problem. The test was supposed to run during the day shift on April 25th, with the reactor stable at 700 to 1,000 megawatts thermal. But a grid controller in Kiev, facing unexpected demand, refused to release Reactor 4 from the network. The test was delayed hour after hour. By the time the night shift arrived at midnight, the reactor had only just begun its final power reduction. At 12:28, with the reactor at roughly 500 megawatts, control transferred from the local to the automatic regulating system. Something failed. The power did not stabilize, it collapsed. Within seconds, the reactor plunged to just 30 megawatts. Inside the core, decaying iodine 135 flooded the fuel channels with xenon 135, a neutron poison that smothered the chain reaction like a wet blanket. The reactor was now deeply poisoned, unstable, and dangerous. Alexander Akimov, the shift supervisor, wanted to abort. He was overruled. Anatoly Dyatlov, the deputy chief engineer, 14 years of naval reactor experience, a reputation for iron discipline, insisted the test continue. He threatened to hand the shift to the previous operator if Akimov refused. The operators complied. One by one, boron carbide absorbers slid upward out of the core, stripping away layer after layer of safety margin. By 100 hours, the reactor had crawled back to 200 megawatts, far below the test specification, but Dyatlov declared it sufficient. What no one in that room fully grasped was the geometry of the disaster now assembling around them. The operational reactivity margin, the number of control rods still inside the core, had fallen to approximately 8. The rulebook mandated a minimum of 15. The reactor was a coiled spring. Then, between 103 and 107, 2 additional cooling pumps were switched on, as the test protocol required. The surge of colder water through the core further suppressed reactivity, forcing the operators to withdraw still more control rods. Steam drum pressure destabilized. Alarms flickered across the panels. To prevent the automatic safety systems from aborting the test, the operators disabled the steam drum emergency protection. At 1 hour, 23 minutes, 4 seconds, Akimov gave the order. The turbine feed valves closed. The test was underway. Coolant flow dropped. Inside the core, steam bubbles began to form, and the positive void coefficient, that forgotten design flaw, began to feed upon itself. For 36 seconds, the instruments reported stable conditions. Then, at 1 hour 23 minutes 40 seconds, Toptunov pressed the AZ5 button, the scram command meant to insert all 211 control rods and shut the reactor down. What happened next was a catastrophe engineered into the geometry of the rods themselves. Each control rod carried a graphite displacer at its tip 4.5 meters of graphite, shorter than the 7-meter core. When the rods began descending from their fully withdrawn position, the graphite tips entered the bottom of the core first, displacing water and locally increasing reactivity. Instead of stopping the reaction, the scram accelerated it. Power surged past 530 megawatts in under 3 seconds. Fuel channels ruptured. Steam pressure hurled the 1,000-ton reactor lid from its mountings. At 1:24, the control room shook with 2 explosions. The roof of Reactor 4 tore open to the night sky. The graphite moderator, exposed to air, ignited. The men in the control room, Akimov, Toptunov, Dyatlov, did not yet know that the dose they had already absorbed would end their lives within weeks. The Chernobyl disaster was not one decision, but a cascade of them, each defensible alone, catastrophic together. A design flaw kept secret, a test delayed into the dead of night, safety systems disabled by hand, a shutdown button that, due to a hidden defect, became the trigger for the explosion it was meant to prevent. The lesson is not that the operators were reckless, it is that systems without transparency, where safety cannot speak above production quotas, are systems waiting to fail. If this story has stayed with you, please subscribe and comment below. Which moment in that control room sealed Chernobyl's fate?